Hey friends, welcome back for another video, and today we are going to be talking about rules of exponents. This is just a common area where I see, simple little mistakes that kind of impact the rest of the problem, and, whether you just need a refresher on this or you're learning this for the first time, this is for you. And so looking at this very first problem here, x to the fourth times x to the third. And maybe you know the answer already, but again, we're trying to explain why this, how this works out. And so we're going to take just this first thing here, x to the fourth. And all right, this little exponent of 4, that means, it's kind of rules of math, like a notation, okay, how things are written and expressed. An exponent means repeated multiplication. And so we're going to take our x to the fourth and we're going to expand it. We are going to show that it's 4 copies of x being multiplied. And then I'm going to do a similar thing over here with x to the third. That means we have 3 copies of x multiplied to each other, x times x times x, right here. Now, we have the same number being multiplied to itself multiple times here. And so how many of them do we have? Well, we count them all up. This ends up being 7 copies of them. And so to kind of condense that so we don't have to write out 7 copies of x every time, we write x to the 7th. And so what's our answer over here? It is x to the 7th. Now, you might notice that 4 and 3 and 7 kind of have this relationship together, because what is this really? Well, if we take x to the 4 plus 3, if we add those exponents, my goodness, we get x to the 7th. And you can do this for any type of number, any number of exponents, whether it's negative, positive, whatever. This is always going to be the case that we can add the exponents. And so our shortcut here is going to be adding them. All right, if we are ever multiplying numbers that have exponents to them, they're like terms, we can add the exponents and be in a good place. All right, next problem here. We have x to the 5th divided by x to the 2nd. Well, again, let's long form this. So taking the top here, just the top piece, we have 5 copies of x being multiplied to itself. X by x by x by x, all right, by x, I think. Missed one in there. And then in the bottom here, we have x to the 2nd, so 2 copies of x being multiplied to each other. And then we want to simplify if we can. Well, we look at the top here, all right, we have an x up top and an x in the bottom. These x's are being divided, this bottom x here is being divided into that top one, or kind of our top set of x's here. And so we can actually cancel that, because a number divided by the same number is going to be, they're not going to be 0, they're going to be equal to 1. So we can say 1 and 1, right? And then we could do the exact same thing with this second x here, this guy and this guy. So we can cross them off and say, okay, those divide out to be 1 and 1. All right, what are we left over with? Well, we have 3 x's up top times the number 1 times another number 1. On the very bottom, we have 1 times 1. Well, we know, all right, I'll write it out just for the sake of things. So we have 3 copies up top. That's going to be x to the 3rd divided by a 1 on the bottom. Well, any number, regardless of what it is, if we divide 1 into it, it just ends up being that number. It's going to be x to the 3rd. And again, what's the relationship? What's happening here? What's a shortcut that we can form? Well, you might notice that x to the 5 minus 2 is equal to x to the 3rd. And that's going to be our shortcut. Again, no matter what numbers we throw in here, our shortcut is going to be to subtract them. If we're ever dividing exponents, again, the base number is the same. It's always x or, y, whatever variable or number. That's going to be our shortcut, is to subtract them. All right, x to the negative 3. All right, what we do here is negative exponents always flip. And so what our result's going to be here is x to the 3rd. We flip where it's from, and then we change it. To take another example, let's say we had a situation like this. We had 1 over x to the negative 3 in the bottom there. Well, regardless, we are going to flip it. So if it's in the denominator like it is here, we are going to flip it up top. So 1 times x to the positive 3, we flip its position, which is just equal to 1 times a number is just the number x to the third. So what's our shortcut? Negative exponents, we flip them. All right, final one here, x to the 0. No matter what, regardless of the number, whether that number is big, small, negative, imaginary, whatever, if you take a number and you take it to the 0 power, the result will always, always, always be 1. And so, what is our shortcut? All right, we are going to 1 them. If we ever have something to a 0 power, we are going to get 1. Now, I did not explain that at all, why that's the case. I might do another video about that in the future, but for now, take my word for it. X to the 0 power, or any number to the 0 power, is always going to be 1. Now, to review. So, if we are multiplying exponents, again, same basis, same numbers are being multiplied with exponents, our result is that we add them. If we are dividing exponents, we just subtract those numbers from each other. We subtract them. If we have a negative exponent, our result is that we flip them. And if we have something to the 0 power, our result is we 1 them. And so hopefully this was helpful for you. Let me know in the comments if you have any questions about anything or if there's any type of content that you would like to see. Take care, everybody.